Hello student, this video is a continuation to the previous video where we have started the MCQ type problems based on the multiple integral. There we have discussed some problem based on the double integration, how do we find out the area, how do we change the order of integration part also. So now let us continue with the next problem. Okay, so the last problem we have discussed where we need to convert the double integral into the polar form. In case of polar form, that means we find that if the region is a circle, then we know that x equal to r cos theta, y equal to r sin theta. This is the transformation we are using when we transform the Cartesian coordinate into polar coordinate system form, and x square plus y square we get it equal to r square. So x square plus y square is equal to r square, and the limit of r, because it is a circle whose center is origin, then the distance, the limit of r varies from origin to the boundary, and because this is nothing but the radius, and the radius of a circle is fixed, so the limit of r varies from 0 to the radius of a circle, and the limit of theta varies from 0 to 2 pi if it is a complete circle. And in case of polar coordinate system, dx dy will be equal to r dr d theta. So basically this is one of the important results. Now let us move to the next question. So in this question, we want to represent the equation of a circle in polar form. So the equation of circle is given as x square plus y square equal to 4y. So in polar form, we are using the transformation x equal to r cos theta and y equal to r sin theta. So what will be x square plus y square? This is equal to r square. So if we substitute this value in this equation, so the equation is x square plus y square equal to 4y. So x square plus y square is r square and y is r sin theta. So if we combine them, r is common, r minus 4 sin theta equal to 0, or you can say that r equal to 4 sin theta because r should not be equal to 0. So what kind of equation is? The equation is r equal to 4 sin theta. So this is the representation of the equation of circle in polar form. Okay, now let us move to the next question. Next question is, we want to find out area bounded by the circle x square plus y square equal to 4 and x square plus y square equal to 1. So basically, it gives us two equation of circle. One circle whose center is origin and radius is 1, and another one is x square plus y square equal to 1 square, and x square plus y square equal to 4 means equal to 2 square. So it is the equation of a circle whose center is origin but radius is 2. So it is a bigger circle. So we are interested to find out the area of this ring. We want to find out the area of this ring. So what we are going to do here, so in this case, say this is our x-axis, this is our y-axis. So whenever the region is the circle, we preferably transform Cartesian coordinate into polar coordinate system. Okay, so basically we get here x square plus y square varies from 1 to 4. So because it is a part of the circle only, the ring is a part of a circle. So in this case, we preferably convert it into polar form. So in polar form, we convert x equal to r cos theta, y equal to r sin theta. So x square plus y square is equal to r square. So because the region is a circular ring, so we transform rectangular coordinate system xy to the polar coordinate system r theta using this transformation. Okay. So if I substitute here x square plus y square is r square. So the value of r square varies from 1 to 4. So the limit of r varies from 1 to 2. So in this case, the value of r not started from origin, because in this case, I want to cover this particular area. In this case, the limit of r varies from 1 to 2. But it is a complete circle. So this angle is theta. So what can we do here? So we have started with this particular wedge from 1 to 2, and then from x-axis we simply rotate it as a complete angle. Automatically it will construct a ring. So what is the limit of r? R varies from 1 to 2, but the value of theta varies from 0 to 2 pi, because it is a complete circle. Okay, and what about dx dy? Dx dy will be r dr d theta. What will be the area? Area is double integral dx dy over the region R. This is the limit of r varies from 1 to 2, and dx dy is r dr d theta, and the limit of theta is 0 to 2 pi. So again, the limit of integration is constant. I told you, in case of double integral, if the limit of integration is constant, so we can separate the two integral as a product of two integral. So outer limit is the limit of theta, and the inner limit is the limit of r. So integral d theta is theta with the limit 0 to 2 pi. Integral of r is r square by 2 with the limit 1 to 2. So on solving this, we get 2 pi, and here it is upon 2 common, 2 square 4 minus 1. So answer will be equal to 3 pi. The correct answer is option D only. Okay, now let us move to the next question. Okay, again we want to transform this integral into polar form. So firstly, we'll try to see that what is the given region here. So inner limit is a function of x. So it means that the limit of y started from 0 and at square root of 1 minus x square, and the limit of x varies from minus 1 to 1. Okay, so it means the region is y equal to 0 and y equal to square root of 1 minus x square, x equal to minus 1 and x equal to 1. So this is y square equal to 1 minus x square, or x square plus y square equal to 1. Means it is a circle. So it is a circle whose center is origin and radius is 1. But we are given the variable limit as y. So the limit of y varies from 0. So y equal to 0 means x-axis. This is x-axis, this is y-axis. The limit of y varies from 0 to the circle, is we are given a vertical strip, and the limit of x varies from minus 1 to 1. So basically the upper half circle, means a semicircle. So in case of, because it is again a part of a circle, so basically this is the region. So when we convert it into polar form, so we are going to transform xy to r theta using the transformation x equal to r cos theta, y equal to r sin theta, x square plus y square is equal to r square. So what is the limit of r? Because the radius of a circle is 1, the value of r varies from 0 to 1. But because it is a semicircle, so the value of theta varies from 0 to pi. The value of theta varies from 0 to pi only, because it is a semicircle. The value of x varies from minus 1 to 1. Okay, so x equal to minus 1 means r cos theta equal to minus 1. Okay, and uh, because the radius is equal to 1. So it means that cos theta equal to minus 1. So it means theta equal to pi. Okay. So the value of theta varies from 0 to pi because it is a semicircle. Semicircle means the value of theta varies from 0 to pi only, and dx dy will be r dr d theta. So we substitute all this value in this integral. So minus 1 to 1, 0 to square root of 1 minus x square plus y square dy dx. Now this can be written as the limit of theta is 0 to pi. The limit of r varies from 0 to the radius of a circle. X square plus y square become r square, and dy dx become r dr d theta. So its value is 0 to pi, 0 to 1 r cube dr d theta. So the correct answer is 0 to pi, 0 to 1 r cube dr d theta. So why the limit is pi? Because the region is a semicircle, because the value of y is positive. Y is positive means upper half. Okay. And if the value of x is positive, y is negative means again it is a semicircle, but in that case the value of theta varies from minus pi by 2 to pi by 2. If we have a semicircle in this way, then the value of theta varies from minus pi by 2 to pi by 2. Okay. Because sometimes we are given integral in this way, that integral 0 to 1 integral minus square root of 1 minus x square to 1 minus x square means the value of y varies from circle to circle, but the value of x varies from 0 to 1. So in that case, the radius will remain same, but the value of theta varies from minus pi by 2 to pi by 2. Okay, let us move to the next question. So this time we want to evaluate the integral. The limit is already given to us. So this is 0 to pi by 2 integral of dr, because the inner limit is a function of theta. So this is the limit of r. Integral of dr is r. So this is 0 to pi by 2 upper limit cos theta. So integral of cos theta is sine theta with the limit 0 to pi by 2. So this is sine pi by 2 minus sine 0. So sine 0 is already 0 and sine pi by 2 is 1. So the answer is 1 only. This is a simple problem. Okay, so now we move to the problem based on the triple integration. This is a problem of the triple integration. So in this case, the limit of integrations are already given to us. So in this case, your innermost limit depend upon the variable x and y, both. So it means that out of three variable, which variable is missing? Z. So it means that this limit is of variables. Then the second integral, its limit containing variable x. So z is already over. So it means that it containing variable x. So which variable is missing? Y. It means this limit is a variable y. Automatically the outermost limit is a variable x. Okay. So how do we evaluate this integral? So when we integrating with respect to one of the variable, we are treating the variable as a constant. So integral of dz is z with the limit 0 to x plus y. Sorry, dy dx. So 0 to 1, 0 to x. Integral upper limit is x plus y, lower limit is 0. So dy dx. So now we integrate with respect to y. When we integrating with respect to y, then x is treated as a constant. So the integral of x is constant taken outside. Integral of x is y, and integral of y is y square by 2 with the limit 0 to x dx. So again on substituting limit, so this is x x minus 0. This is 1 by 2 x square minus 0 dx. So this is 0 to 1 x square plus 1 by 2 x square dx. So it is 0 to 1 times 3 by 2 times x square dx. So 3 by 2 is constant taken outside. Integral of x square is x cubed by 3 with the limit 0 to 1. 3 and 3 get cancelled out. So 1 minus 0 answer is 1 by 2. So the correct answer is option C. This is a simple problem. Means when we are integrating with respect to one of the variable, the other variables are treated as constant. And what is the integral of constant dx? So constant can be taken outside. Integral of dx is x. So this is the rule of integration. Sorry. Let us move to the next question. Okay. So the question is, if V is the volume bounded by x square plus y square plus z square is less than equal to x, then what is the limit of R is? So basically, if you just look at here, x square plus y square plus z square is less than equal to x. So this is x square minus x plus y square plus z square is less than or equal to 0. So this is here we are going to complete the square. Half the coefficient of x is 1 by 2. It's a square, adding and subtracting. So adding and subtracting 1 by 4. So this is x minus 1 by 2 whole square plus y square plus z square is less than equal to 1 by 2 square. So this is basically the equation of sphere. This is the equation of sphere whose center lies on x-axis. This is the equation of sphere whose center lies on x-axis. So say this is x-axis, this is y-axis, and this is z-axis. So this is the center whose center is at the point 1 by 2, 0, 0, and radius is 1 by 2. So it means that this is a sphere like this, which passes through the origin also. So this is the shape of the sphere we have, whose radius is 1 by 2. So what we need to do, we need to convert it into spherical polar coordinate system. So firstly, we need to understand the spherical polar coordinate system, right? Let us consider one additional slide here. So what is the spherical polar coordinate system? So in this case, we are going to transform the variable x, y, z to r, theta, and phi. So say this is the origin, and I'm assuming the sphere as x square plus y square plus z square equal to a square. So this is a sphere whose center is origin and radius is a. So this is a sphere. So I'm considering any point on the boundary of the sphere is x, y, z. Okay, so if I want to transform into spherical polar coordinate system r, theta, and phi, so what we are going to do, firstly I join this point with the origin, and I'm saying that say this distance is r, and let us suppose that the angle with z-axis. So this is z-axis, this is x-axis, and this is y-axis. So this angle with z-axis is theta. Then let me consider here only. So this is r, okay, and this angle is theta, and here this point is xyz. Okay, so I'm taking a projection of this particular point in the xy plane. So this is xy plane, this is zx. So if I take its projection in the xy plane, its coordinate will be xy0 and this distance is z. And now I'll join this point with the origin. Okay. And I'm taking its perpendicular on x-axis. So if I take this perpendicular on x-axis, this line is parallel to this line and this line is parallel to x-axis. So this distance is x, this is also x, this is y, this is also y. And let us suppose this angle is a phi. So firstly, so because this angle is theta, this angle is also theta, alternate angle, right? So now I'm considering this right angle triangle. This right angle triangle. This right angle triangle means I'm considering this triangle. This angle is theta. This is R. This is Z. Okay. And this is say A, O, A, B. So Z upon R. This is base because this is a perpendicular. So base upon perpendicular, Z upon R equal to cos theta. So what is Z? Z is equal to R cos theta. So what about OB upon R? This is equal to sine theta. So it means that OB is equal to R sine theta. Okay. Now OB is R sine theta. So now we are considering this right angle triangle. This right angle triangle I am considering here. So right angle triangle I am considering OB because I assume it as B and say this is C. So I am considering O, B and C. Now OB its value comes out to be R sine theta. What is the BC? BC is Y. Sorry, this angle is phi now. Phi with OC. I'm considering this as O. X is base. This is base, and this is a perpendicular. BC is perpendicular. Okay. This is Y and this is X, and this angle is phi. And this angle is, if this angle is phi, this angle is 90 degree. This angle is 90 minus phi. Or I can consider triangle in this way. This is X, this is Y, this is O, this is R sine theta, this is R sine theta, this angle is phi, so this is perpendicular, perpendicular BC is the perpendicular. So basically this B, C and O. Now OC is X, this is Y and this is B and this angle is phi. So base upon hypotenuse X upon R sine theta. This is cos of angle phi. So the value of X is R sine theta cos phi and perpendicular upon Y upon R sine theta is sine phi. So Y is R sine theta sine phi. So this is the transformation we are going to use in case of spherical polar coordinate system, right? So what is the transformation? Let me rewrite here in the next slide. So transformation we are using Z equal to R cos theta, X equal to, if R cos theta is there, then in X and Y we are using R sine theta. Okay. And with this we are using cos phi and sine phi. so that when we squaring and adding x square plus y square is equal to r square sine square theta common cos square phi plus sine square phi is 1, right? And if we add x square plus y square plus z square, then this is equal to r square sine square theta plus r square cos square theta. It is equal to r square. So x square plus y square plus z square equal to r square, which is the equation of a sphere. Okay. And now we'll see how do we construct a sphere. So in case of sphere, how do we construct it? So we are saying that suppose we started from a region and we move a distance up to the boundary of the sphere, which is the radius, and we say it is as r. Then with the z-axis, we construct the angle theta. That means with the z-axis, we construct one semicircle. So what is the limit of theta? Theta varies from 0 to pi. And what is the limit of r? 0 to the radius of the sphere. Okay, so we construct a semicircle means the value of theta varies from 0 to pi. And then we are going to rotate this sphere in xy plane. So when we give a complete rotation means that this angle is phi. So the limit of phi varies from 0 to 2 pi. Okay, so basically we are taking one rotation in the xy plane. So in xy plane, we are constructing one circle, which is a variable circle. And we already know that in case of polar form, what is x-axis? R cos phi, r cos theta, and y is r sine theta. So because in this case it is a variable form, because we are going to, because the radius of the sphere is the same throughout. So when we are going to construct it to make it a sphere, so that throughout the radius of the sphere will remain same. So in this case, x and y, they having variable r. This particular circle with variable r. So what is r in this case? It is r sine theta. Otherwise, it is a circle only in xy plane. Okay. So the transformation we are using x equal to r sine theta cos phi, y equal to r sine theta sine phi, and z equal to r cos theta. And with this particular limit, we can construct the sphere. But what about dx dy dz? Dx dy dz is equal to Jacobian of transformation time dr d theta d phi. And what is the Jacobian of transformation here? It is Jacobian of x, y, z with r, theta, and phi, which is equal to curly x upon curly r, curly x upon curly theta, curly x upon curly phi, curly y upon curly r, curly y upon curly theta, curly y upon curly phi, curly z upon curly r, curly z upon curly theta, curly z upon curly phi. So if we solve this, so what is the derivative of x with respect to r? This is sine theta cos phi. Derivative of x with respect to theta, r cos theta cos phi. And derivative of x with respect to phi. So r sine theta is constant. Derivative cos phi is minus sine phi. So it is minus r sine theta sine phi. Similarly, derivative y with respect to r is sine theta sine phi. With respect to theta, r cos theta sine phi. With respect to phi is r sine theta cos phi. And z with respect to r cos theta, z with respect to theta minus r sine theta, and z with respect to phi is 0. Now to calculate this Jacobian, we need to expand this determinant. Suppose that I'll expand it through third row. We expand through third row. So what is the coefficient of cos theta? This into this. So Jacobian of transformation is equal to r, sorry, cos theta into this r cos phi. It is common. R cos phi into r cos phi. It is r square cos phi into r square cos phi, r square cos square phi, r square cos square phi into cos theta sin theta into cos theta sin theta minus this into this minus this into this. So here r sin phi is common. Negative sign is one already there, so it is positive. So r square sin square phi into sin theta cos theta. R square sin square phi into sin theta cos theta. Then we have a negative sign. So one negative sign is already there, so it is plus r sin theta time. Now again, now we are going to consider this column and this row. So we multiply this with this. So sin theta cos phi is common. So r sin square theta cos square phi, r sin square theta cos square phi. Then again this into this. Negative become positive. R sin square theta sin square phi plus r sin square theta sin square phi. So if we solve this, cos theta is already there. So cos theta sin theta is common. R square is common. Cos theta sin theta is common. So we have cos square phi plus sin square phi because r square and cos theta sin theta. R square and sin theta cos theta is common. So we left with cos square phi plus sin square phi, which is 1. And here r sin square theta is common. So r sin theta is already there into r sin square theta is common. So we have cos square phi plus sin square phi. Cos square phi plus sin square phi is again 1. So this term is 1. This term is 1. So now we left with only this term and this term. So this is equal to r square cos square theta sin theta plus r square sin cube theta. So r square sin theta is common. So we left with cos square theta plus sin square theta. Cos square theta plus sin square theta is 1. So its value is r square sin theta. So what is the Jacobian of transformation? Jacobian of transformation is r square sin theta. R square sin theta dr d theta dy. Okay. Now let us come back to the question. So because in this case the surface is a sphere, so what we need to do, we need to convert it into spherical polar coordinate system. So we are going to transform x, y, z to r theta phi. So using the transformation, what is the transformation? Z equal to r cos theta, x equal to r sin theta cos phi, and y equal to r sin theta sin phi. So what is x square plus y square plus z square? This is equal to r square. So we substitute this value here in this equation. So we get x square plus y square plus z square is less than equal to x. This is r square. And what is x? R sin theta cos phi. So r is common. R minus sin theta cos phi is less than or equal to 0. So it means that either r equal to 0 or r equal to sine theta cos phi. So what is the limit of r? So it means that the limit of r varies from 0 to sine theta cos phi. So what is the correct answer? The correct answer is option D only. So what is the limit of r? 0 to sine theta cos phi. Okay, even you can see here, if this is a sphere, the value of r started from origin, but in this case, as we move, as we rotate, that means this is the angle theta. If we rotate, the value of theta value of r start increasing. Here r is 0. So when we increase the value of theta, the value of r firstly start increasing. Here it attain its maximum value and then again start decreasing. But if I rotate it in this particular direction, again the value of r increasing. So increasing or decreasing, because we need to move in two directions. One is this side, another one is this side. So it means it's depend upon theta as well as phi both. And how it relates? So we simply substitute the transformation term in the given equation. That will directly gives us the limit of r. Okay. So this is the limit of r in this question. So here we basically use simply the spherical polar coordinate system transformation to get the limit of r. Okay, let us move to the next question. Okay, firstly because we have already discussed the spherical polar coordinate system part, so we'll consider this problem. The question is the volume of one octant of the sphere is. One octant means, so like I have already discussed that this is a complete sphere. This is a complete sphere. So this is x-axis, this is y-axis, this is z-axis. So if I cut this sphere by the xy plane, okay, so it means that it will be divided into two halves. So one part of the sphere lie above the xy plane, one part lie below this xy plane. And this can be cut into four parts, right? One is that because we have a four quadrant, if I take its projection is a circle which has a four quadrant. So it means that it is a four part above xy plane, four part below xy plane, right? So one of such part is called the one octant. So the volume of one octant means that suppose I can consider the first octant. First octant means where x, y, z all three variables are positive. Okay, so what will be the volume in that case? How do we calculate it? So to calculate this, firstly, we are going to transform it into spherical polar coordinate system. R x equal to r sine theta cos phi, y equal to r sine theta sine phi, and z equal to r cos theta, such that x square plus y square plus z square equal to 1 r square. But because here, if I substitute this value, it means r square equal to 1. So it means that the limit of r varies from 0 to 1. So the limit of r varies from 0 to 1, right? But in this case, because I need to consider the volume of one octant, first octant only, right? So in the case of first octant, the limit of varies from 0 to pi by 2 only, because up to xy plane, because we are not going to construct the complete sphere. So it means that firstly I construct a theta varies from 0 to pi by 2, and then we also rotate phi angle up to pi by 2. So automatically it will construct the octant. So in this case, the limit of r varies from 0 to 1, theta varies from 0 to pi by 2, phi varies from 0 to pi by 2, and what will be dx dy dz? This is equal to r square sine theta dr d theta d phi, because we have already calculated the Jacobian of transformation. So what is volume? Volume is triple integral dx dy dz. So this is equal to 0 to pi by 2, 0 to pi by 2, 0 to 1 r square sine theta dr d theta d phi. So this is the volume of one octant of the sphere. The limit of r is 0 to 1, limit of theta is 0 to pi by 2, limit of phi is 0 to pi by 2. Okay, so because here the limit is 0 to pi by 2, that should not be limit of r. So it means that the option is B, but it is not written in proper order. It should be in the form of d theta, d phi, and dr because the outermost limit is of variable r. Okay, so this is the correct answer. Otherwise, that the limit of theta and phi both are pi by 2 only, and Jacobian of transformation is r square sine theta. Okay, now let us move to the next question. The next question is the volume bounded by the cylinder. What is the cylinder? Basically, if we consider a circle in a three dimension, it will construct an infinite cylinder because in this case x square plus y square equal to 1 is a circle in xy plane. So if there is no restriction on z axis, it will construct an infinite cylinder, right? But in this case, it is bounded by the plane z equal to 0 and z equal to 4. So in this case, it is bounded by z varies from 0. Z equal to 0 means xy plane. So it means that otherwise this is the infinitely extended cylinder like this. So if it is bounded by this plane z equal to 0 means I cut by this plane and I cut by this plane here. Here z equal to 0, here z equal to 4. So it means that this is a bounded cylinder. So how do we calculate the volume? Volume is given by triple integral dz dx dy. So in case of the volume of the surface, we firstly consider a small piece of cuboid and we move vertically from surface to surface. Okay, so in this case, it will start it from the surface z equal to 0 and it move up to the plane z equal to 4. So the limit of z varies from 0 to 4, fine. But when we take its projection, now to find out the limit of x and y, we are taking the projection of the surface in xy plane. So the projection of the surface is a circle. Projection of the surface is a circle. Circle equation is x square plus y square equal to 1. So we have a two option. Either we move horizontally or we move vertically. So if you just look at here, the limit is given y in term of x. Okay, so it means that we consider a vertical limit first. So the limit of y started from circle and at a circle. So what is the value of y here? In the below x-axis, the value of y is negative, so it is minus 1 minus x square 2 plus 1 minus x square square root. Y varies from curve to curve, that is circle to circle, and the value of x varies from boundary to boundary. Because the radius of the circle is 1, so the coordinates are minus 1, 0, 1, 0. So boundary is minus 1 to 1. So what is the limit of y? Minus square root of 1 minus x square to square root of 1 minus x square. And the limit of x varies from minus 1 to 1. Okay. So the correct answer is option, it should be option B. Maybe it is not correct printing. It should be negative sign from minus square root of 1 minus x square to square root of 1 minus x square. This is the limit of y. X is minus 1 to 1 and z is 0 to 4. Because all other options are wrong. So this is the only correct option we have. Okay. So it means that the limit of z varies from 0 to 4. Limit of y varies from minus square root of 1 minus x square to square root of 1 minus x square. And the limit of x varies from minus 1 to 1 dz dy dx. So this is the representation of the volume of cylinder in xyz. Otherwise, if I want to calculate the volume of the cylinder after taking the limit of z when we take its projection, because the projection is a circle, so we convert it into polar form. The limit of r varies from 0 to 1 and the limit of theta varies from 0 to 2 pi. We convert it into polar form and we can get the limit because it is a complete circle. And dx dy is converted into r dr d theta. So in cylindrical polar coordinate system, it can also be written as 0 to 2 pi, 0 to 1, 0 to 4, r d dz dr d. This is the representation of the volume of the cylinder in polar coordinate system. This is the polar coordinate system, cylindrical polar coordinates. Okay, now let us move to the next question. Okay, the next question is volume bounded by the curve is given by. So in this case, we are given the three surfaces. So we want to find out the volume bounded by the surface. So firstly, we need to draw the rough sketch of the surface. So say this is our x-axis. Okay, so we are considering this side y-axis. This side we are considering x-axis, and this side we are considering z-axis. Why? Because we are given a line equation y plus z equal to 4, which is in yz plane. Okay, but otherwise it is a plane. It is the equation of a plane in 3 dimensions. Okay, so y plus z equal to 4 means we write the intercept form. When z equal to 0, the value of y is 4, and when y equal to 0, the value of z is 4. So it intersect at the point 0, 0, 4. So join them. So this is the plane. Also, we are given xk plus y square equal to 4. So it is the equation of a circle in xy plane whose radius is 2. So it is a circular shape like this. So it is a cylinder like this. So it means that this particular plane cut this cylinder in this way, and also bounded by the plane z equal to 0. So it means that it is bounded by this plane z equal to 0. So basically we have this portion of the surface. I want to find out the volume of this part. Okay. So to find out the volume of this part, first step is we need to calculate the limit of z. So for limit of z, we simply consider a small piece of cuboid and we move vertically. So when we move vertically, the limit of z started from the plane z equal to 0 and end up to the plane z, this plane. Okay, and what is this plane? Y plus z equal to 4. So because as I move toward this side, the value of z start increasing. So it means the value of z depend upon this plane only. Okay, it is not constant. So what is the value of z along this plane? This is 4 minus y. So according to that, the limit of z varies from 0 to 4 minus y because it has a shape like this. The shape of the surface is like a circular cylinder, but it is inclined from the top. Okay, it has a shape like this. So as I move toward this side, the value of z varies. Okay, so because it has a shape like this. So it means that here the value of z is 0, here the value of z is 4 minus 5. So this is the limit of z. But after that, when we take the projection of this surface, the projection of this surface is the xy plane is a circle. This is x-axis, this is y-axis, whose center is origin and radius is 2. So this is a point 2, 0. This is a point 0, comma 2. This is minus 2, 0. And this is 0, comma minus 2. So the next step is we need to find out limit of x and y. So if I simply take the limit in x and y, then the limit of x started from the circle, and at the circle, and the limit of y varies from boundary to boundary. So what is the limit? The limit of z varies from 0 to 4 minus 5. The limit of x varies from minus square root of 4 minus 5 squared to 4 minus 5 squared. And the limit of y varies from minus 2 to 2. Okay. Surface to surface, the limit of z. Curve to curve, limit of x. Boundary to boundary, limit of y. So if we check it here, then we find that the correct answer is option B. 0 to 4 minus 5, this is the limit of z. Minus square root of 4 minus y square to 4 minus y square is limit of x, and limit of y minus 2 to 2. So this is the represent. And what is volume? Volume is basically triple integral dz dx dy. So this is the limit of z, this is the limit of x, and this is the limit of y. Hence, this is the representation of the volume of the surface. Okay. Otherwise, I told you whenever if we want to calculate the volume, in that case, we preferably converting a circle into polar form. So in this case, the limit of r varies from 0 to 2, and the limit of theta varies from 0 to 2 pi because it is a complete circle. And dx, dy, dz will be converted into r, dr, d theta, dz. Okay, because in this case, z remains same. So dx, dy is converted into r, dr, d theta. Okay, so that is the representation of the volume in the polar coordinate system also. The limit of z is 0 to 4 minus y, and then we convert it into r and theta after solving this particular integral. Okay, because y will be replaced with r sine theta. Okay, because x is r cos theta and y is r sine theta, and x square plus y square is equal to r square. But this could be done only after calculating the limit of z. Okay, now let us move to the next question. Now here we want to evaluate the integral of 1 upon x y z, where the limit of integration is constant. And I told you if the limit of integration is constant, we simply separate the integral 1 upon z dz, 1 upon y dy, 1 upon x dx. And we know that integral 1 upon x dx is log of x. So we use this property. This is log of z with the limit 1 to e, log of y with the limit 1 to e, log of x with the limit 1 to e. So log e minus log 1, log e minus log 1, log e minus log 1. Log e is 1 and log 1 is 0. So 1 into 1 answer is 1 only. Okay, now let us move to the next question. So this is the question based on spherical polar coordinate system. But here there is a change. If you remember, we have discussed that we are using the transformation x equal to r sine theta cos phi, y equal to r sine theta sin phi, z equal to r cos theta. That means theta is the angle which we made with z axis. But here they have made phi angle with z axis. Okay, and theta angle in the xy plane. Okay, so this is the difference. So what is the Jacobian of transformation if we are choosing x equal to r sine theta cos phi, y equal to r sine theta sine phi, and z equal to r cos theta? Then the Jacobian of transformation is r square sine theta. So if we change theta with phi, then the Jacobian of transformation will be r square sine phi. Okay, so this is the important thing you need to remember. Generally, we are using this particular transformation only. If there is any change, if anything is specified over there, then accordingly we need to write the Jacobian of transformation and we need to find out the limit of phi and theta accordingly. Okay, so we are assuming theta is an angle which we made with the z-axis. This is the angle theta, and the value of theta varies from 0 to pi, and phi is the angle which we made in xy plane to complete this circle, and hence we can convert a semicircle into a sphere. First we construct a semicircle, and when we rotate this semicircle in xy plane, this semicircle will be converted into a sphere. Okay. Okay, now let us move to the next question. So the next question is volume of the solid bounded by the plane. Okay, so we are given, say this is x-axis, y-axis, z-axis. It is bounded by the coordinate planes. So it means that z equal to 0, this is a plane. X equal to 0 means yz plane. So it means this is the plane and this is the plane. Okay. And we are considering one plane x plus y plus z equal to a. X plus y plus z equal to a, it will meet the xy plane at z equal to 0. So it meet x-axis at the point when y and z they are 0. It means at the point a 0 0, y-axis at the point 0 a 0, and z-axis at the point 0 0 a. So it means that this is the shape of the plane. Okay, so it has a triangular shape in all the side, and basically it is an inclined surface. Means if I take its projection in the xy plane, everywhere we'll get a triangle only. Okay, but this is a inclined triangular plane, like a prism, you can say. Okay, so when I want to find out the limit of z, we started from z equal to 0 and up to this surface. What is this surface? This is surface x plus y plus z equal to a. So what is the limit of z? A minus x minus y. Okay, I told you the limit of z varies from surface to surface. So the limit of z varies from 0 to a minus x minus y. And when we take the projection of the surface, the projection of the surface is again a triangle in xy plane. It is a triangle in xy plane. This is a line x plus y equal to a, and this is y equal to 0. This is x equal to 0. So if we move vertically, the value y varies from curve to curve. Y varies from 0 to a minus x. And what is the boundary point? A is 0. This is 0 a. So the limit of x varies from curve boundary to boundary, 0 to a. So the limit will be 0 to a minus x minus y, 0 to a minus x, and 0 to a. So this is the correct answer. Okay, now let us move to the next question. So the volume of the sphere. Okay, so like I told you, if I want to find out the volume of the sphere, so we are going to use the transformation x equal to r sine theta cos phi, y equal to r sine theta sine phi, and z equal to r cos theta. such that x square plus y square plus z square sorry equal to r square. But here r square equal to a square, so it means that the limit of r varies from 0 to a. And I told you to construct this sphere. So firstly we construct a semicircle, that is a theta angle which made with z axis with the limit 0 to pi, and then we construct a circle in a xy plane to convert this semicircle into a sphere with the limit phi varies from 0 to 2 pi, and dx dy dz will be converted into r square sine theta dr d theta d phi. So what will be the volume? It is triple integral dx dy dz, that is triple integral 0 to a, 0 to pi, 0 to 2 pi r square sine theta dr d theta d phi. Now again the limit of integration is constant, and the limit of it, so we can separate this integral as a product of three integrals. So I can write it as 0 to 2 pi, this is the limit of phi, 0 to pi, this is sine theta d theta, and 0 to a r square dr. So integral of d phi is phi, integral of sine theta is minus of cos theta, integral of sine theta is minus of cos theta, and integral of r square is r cube by 3. So if we substitute here, this is 2 pi minus 0 is 2 pi. Cos pi is minus 1, so minus 1 minus of cos 0 is 1. So 1 plus 1 is 2, and this is a cube by 3. So 2 pi into 2 into a cube by 3, so answer is 4 pi a cube by 3. So 4 by 3 pi a. Otherwise, we know that what is the volume of sphere? 4 by 3 pi r cube. What is r? A. So we can directly write the answer, but this is how we actually calculate the volume of the sphere by firstly converting it into spherical polar coordinate system, and hence we can get the volume of the surface also. Let us move to the next question. Okay, so this is the problem of the triple integration where the limit of x, y, z are given here. So minus 1 to 1, 0 to z. When we integrate with, because innermost limit depend upon x and z, so it means this limit is of variable y. This limit is of variable y. Okay, so it means that we firstly integrate with respect to y. So x and z are constant. So its integration is y, and integral of y is y square by 2 dx dz with the limit x minus z to x plus z. So basically what I have done, I separate it as minus 1 to 1, 0 to z, 0 to x minus z to x plus z. This is x plus z plus y dy, dx and dz. So on substituting the limit, this is minus 1 to 1, 0 to z, x plus z into upper limit minus lower limit plus 1 by 2, x plus z square minus x minus z square time dx dz. So on solving this, this is minus 1 to 1, 0 to z, x plus z into 2z plus 1 by 2 time x square plus z square plus 2xz minus x square plus z square minus 2xz dx dz. So here x square z square get cancel out. So this is minus 1 to 1, 0 to z. This is 2z into x plus z plus 1 by 2 times 4xz dx dz. Or if we open this bracket, this is minus 1 to 1, 0 to z. This is 2xz plus 2xz, 4xz plus 2z square dx dz. Because now the next limit is the function of z, so this limit is the variable x. So when we integrate with respect to x, so 4z is constant, integral of x is x square by 2, and 2z square is constant, its integral is x with the limit 0 to z dz. So minus 1 to 1, on replacing its z, so 2 1 ka 2 2 ka. So 2z into z square is 2z cube plus 2z cube dz. This is minus 1 to 1, 4z cube dz. Now this is an odd function, so its integral is 0. Because if f of minus x is equal to minus of f of x, it means your function is odd. And in case of odd function, minus a to a f of x dx, this is equal to 0. So even you solve this integral of z cube z power 4 by 4. So minus 1 power 4 is also 1 and 1 power 4 is also 1. So this integration is 0. Okay. So I'll try to include some different problems in this MCQ type problems part. But still, if you have any doubt or any query, you can post your query. I'll try to provide you the solution of the same. Okay. Just practice the problems. Thank you and all the best. Have a nice day.